Hello and welcome to Sudoku. Here is an arrow Sudoku puzzle, which was created by German constructor Christoph Seeliger for the round 8 of Sudoku Grand Prix in 2021. It was one of the highest pointers in the contest with 94 points out of 600, and it was somewhat challenging, but really there is a smooth flow of solving. Well, when I solved it during the contest, I just hope I'll be able to pull it off again. So the rules are that every time you have such let's say a circle or a capsule, then the number that is written left to right is the sum of all digits along the arrow, and of course the classic Sudoku rules apply. So how do you start this? And before really starting, I must say it was my favorite puzzle in the set. All right, here we have sums of many digits. Well, 6 digits. The minimum sum possible is 21 and the maximum is 39. So this should be a 2 or a 3. With 5 digits here, the minimum possible is 15 and the maximum is 35. So this is 1, 2, or 3. With 4 digits, the minimum is 10, the maximum is 30, but 30 would never be written here, so this is 1 or 2. So right from the get-go we get a 1, 2, 3 triple. Here again, those digits should be 1, 2, or 3, but there's a 1 here, so those are 2 and 3. And this here is the sum of 4 digits, so this should be 1 or 2. Let's move on. Here, this is the sum of 3 digits. The maximum is 24, and 1 is not available as the 10th digit. So this is a 2, and this can only be 3 or 4. 21 is not available. 23 or 24. 23 is with 6, 8, 9. 24 is with 7, 8, 9. In which case 7 will have to go there. But there's nothing certain at this point. Here, sum of 3 digits. It won't be in the 20s, so it will be in the 10s. That is a 1. And we know there must be a 1 somewhere here, but I don't think any more than that can be deduced. Now, what about this? Those digits now must be 4, 5, 6, and 8. And something interesting is here the value of this digit and this digit, because we know that all digits on the row add up to 45. And the same will be done here. So this digit plus those digits plus those 2 digits, that's 45. But those digits add up to what is written here. And now, what are the options? So we get the sum here plus the digits of this sum plus this equal to 45. And the same here but with 36. So let's have a look. Well, there are somewhat 8 options, but we'll see that many of them are not possible. Just look at 2 and 8. If we put a 2 and an 8, plus 2 plus 8, that's 38 and this needs a 7 here to finish to 45, so this is not possible. And if we try 26 plus 2 plus 6, this is 34, so we need 11 here, which is not allowed. And if we try a smaller digit here on the units, it will be worse. So we know that this is a 3. So this is 30 something, and this something, so 30 something, so we need another 15, so this digit plus 3 plus this digit plus this is 15. So what would work? So would this work? And obviously this won't work. It's much more than 45. This is 45, so it's not possible either. So let's try with both options. So this is 41, so it would need a 4, but then 4 would be repeated, so this wouldn't work. So it has to be a 5, and this is 43, so we need a 2 here. And this is working. So that was a bit of work to find out about this digit, but that's why the problem is worth so much. Would it work with a 1? I'm almost sure it won't work. If we take the maximum possible, we have 18 plus 1 plus 8 plus 9. This is 36, and to complete to 45 we would need a repeated 9 here. And with a smaller digit than 8, it wouldn't be nearly enough. So this is a 2. And we know the missing digits here are 4, 6, and 8. So let's have a look at which choice will work, or which choices actually. So this makes 39, so it would work with a 6. If I take now 26, 2, 6, 9, this is 43, so it would work with a 2, but 2 would be repeated on the rows, so 6 is not an option. What about 8? Then we get 47, so it will never work. Only 4 is a valid option, and the digit at the end is a 6. Now something similar should be done here, but first let's note that the missing digits here are 4, 5, and 9. And let's have a look at this. Well, with 2, we've already seen that not much is possible. For example, 24 plus 2 plus 4, that's 30, and we would need 15 here. 25, 2, 5, that's 32. We would need 13 here. What about 2 and 9? Well, that's 40. This would work with a 5 to the left. So 29 here would work with a 5. What about 30 something? Well, 34. That's 41. It would need a repeated 4, so that's not an option. 3, 5. So that's 43. It will work with a 2, but 39 is too much. So we have 2 valid options. 2 with a 9 here, and we say a 5 to the right, to the left, and 35 with a 2 to the left. Those are two options for this. But now, will a 2 work here? It seems to be not enough because of this one. So let's have a look. If I try 29 plus 2 plus 9 plus 1, that's 41. Well, this won't work, but not because it's not enough. So 9 won't work, but 2 could be an option, actually. What about 27? That's 37, so an 8 would work. And 8 is still available here. If we try 26, then this is 35, and this is not enough. What was I saying? Yes, 35. This is not enough. We would need a 10. So with 2 as this digit, 7 would work here with an 8 there. What about 3 as the 10th digit? 32 makes 38, so we would need a 7 here, which is not available. 34, that's 42. We would need a 3 here, it's not available. And I think that any higher digit would just break it. That's 41, 42 with the 1. So we need a 3. Did I just study the same? And 34, 35 with a 1, that's 44. We need a 1 which would repeat, and any higher option will break. So this has to be 27 with an 8 here, and we now know that the rightmost option is the right one. And here this is a 4-9 pair. Right, here we need a 6 and a 5. Here we need 6, 9, and 4. And then such a study may be conducted here, or perhaps we should have a look somewhere else. What is the most logical place to look? Perhaps this one, because there might be something about parity. Here we have 10 something, 10 plus this digit, that's the sum of all of this. And if we add this, we have this digit again, plus 1. And what was I saying? No, that's not what I meant. What I meant is that the sum of all those digits is this number, and this number is 9 plus those digits. What I mean is that if this sum is 14, then the sum of the digits is 5. and something similar could have been conducted here. So what I mean is that this digit what am I saying? The sum of all those digits, of those two digits, plus 9 is the sum of this. So we get 2 times this quantity plus 9. For example, if this is 4, making a sum of 5, then we get 2 times 5 plus 9. This plus that is 19. And my point is that this is an odd number. Plus this, that's even, plus this, that's even, but the total sum is odd, so this can only be a 9. And I get this 4 and this 3. And my bet is that it was Christoph's intent to make such reasoning instead of all the brute force I've been doing all this time. Now that I have this 9, I should be able to deduce this digit, because that's 16. So this is 9. Oh, should I really? I'm not sure. I think this digit depends on this one. So let's try. And if this is 6, then we have 22. So the sum of all of this is 23. In which case, this has to be a 6, I think. If I take 6, 7, 9, then, as I say, the sum of all of this is the sum of those two digits plus 9. No, the sum of those two digits times 2 plus 9. So 22, 23, 14. So this plus that must be 7, and it repeats the 6. So this has to be an 8. I'm afraid my video is absolutely impossible to understand. The sum of all three digits here is 24, so the sum here is 21. 21 is 9 plus 12. 12, so the sum of those two digits must be 6, and this is 5. And you can check that the remaining digits, 3, 4, 2, and 6, add up to 15. All right, so my explanations have really not been that great, but then it seems to work. Right, so 23, we know that those digits are 6, 8, and 9. And the remaining digits here are 5 and 7. So this is a 6, this is a 5. Here I need 2 and 8, they are not here, so they must be there. But I won't put 8 here because this is not 1, 2, 3. So the sum here would be at least 12, which doesn't work. So this is 2, this is 8. I get 3 and 7, 3 and 9, using this 3 here. So this is 11. 11 plus that is this. What are the options? 4 makes this a 5. And that's the only way to make it work with the remaining digits. The remaining digits being here 2 and 9. So this resolves all of this, and I get a 9 here. This 4-6 pair disambiguates the 6-8 pair. And those now must be 1 and 7. No, that's not possible. No, sorry, they must be 1 and 5. The remaining digits here include an 8, which is the biggest of them all. So this is 8, this is 6, that's 7, and we get this one and this 5. Here we must have 1 and 8, and 5 and 7. All right. Where do we go from here? Here we need 1, 4, and 6. There's a 1 here. And probably with this 5 I can deduce what the sum is here. 5, that's 22. So the sum of all digits here is 23, so this won't be a 2. 14 would make the sum 19, and 16 makes the sum 26, so this is 23, sorry. I get this 4, this 6, and this 1. Here I need 3, 9, and 7. I need a 2 on this row, so it will be here. This is 3 or 7. I need 3, 4, 5, or 9. There are some constraints. And actually with this 3-9 pair, I get this 4 and this 5. Oh, and the 6-2 is disambiguated on top. At the top, sorry. I need a 6 on this row. It must be here. I also need an 8 and a 7 or 9. So the end should be plain Sudoku. Here I need 8 and 3. There's a 3 here. The 1-8 pair is disambiguated. On top I still need 4 and 9. This is 9, this is 4. And then 1 and 7. And the end just falls apart. Alright, so I'm sorry my explanations were just all over the place. There was some small arithmetics to do, and probably I could have spared some of the brute force at the beginning with just, well, let's say more sensible, more practical computations. Well, thanks for watching this video, and see you soon on Sudoku.